Hi everyone, my name is Sai Vennam and I'm a developer advocate with IBM. Today, I want to talk about security with hybrid cloud architectures. This is going to be part 3 of the hybrid cloud architecture series. Security is a nuanced topic, but to kind of help me explain, I'm going to start with two major concepts of north-south network traffic versus east-west network traffic. When I walked into the office today, I had to pull out my badge and scan to get into the building. This is something called perimeter security and is a core part of north-south network traffic. Essentially what that refers to is any traffic that's traveling from end-user applications to your data centers or public or private cloud environments. Let's take a step back and kind of explain these pieces here. So we've talked about this in the previous videos, but what we've got here is the stock trader monolith, which is going to be on an on-prem data center. We've got a couple of services here, maybe something to help us talk to the cloud and maybe a data store as well. So we mentioned perimeter security, and that's something you take as a given with data centers, that you have that firewall sitting in front of that data center giving you a private network for your actual data center and the applications and workloads running within it. This made security a lot easier to tackle when working with monolithic applications, but it did put the onus of security on the application, the enterprise application developer. The main thing here to actually secure these endpoints was to make sure that all the capabilities that this monolith exposes, those API endpoints, were secured. And to do that, we could take advantage of something like an API gateway. So traditionally what we would see is a gateway that's set up in front of that on-prem application with key capabilities exposed that may be required by that front end to render the application, and potentially the same for a mobile app as well. So that, I think, helps tackle security with north-south network traffic on the on-prem side. But let's shift gears here for a second and talk about the public cloud side, or even potentially a private cloud. I'll talk about the different components here later in the video, but let's start with this piece right here, which is the Kubernetes worker. Within the Kubernetes worker, we can assume that we have a couple of services that we need to actually render the stock trader application, whether it's mobile or in a web app. So we'll have a couple services. We can assume they talk to one another. So what happens when an end user actually accesses that application? Well, one, they'll actually have to hit that endpoint that becomes available, at which point they will enter the public cloud. And at that layer, we get things like denial of service protection and other kind of things that the cloud provider offers you to make sure that those requests are maybe authenticated or they're coming in a safe manner. The next thing that happens is that requests will get forwarded to your actual Kubernetes worker node with the capabilities that it exposes. So at that level, we have a couple of options for securing those endpoints. So let's say we want to hit this first microservice running in our Kubernetes worker. There's two ways that we can kind of configure security policies. The first is going to be at layer 3, which is, if you're familiar, it's things like IPs and ports. Basically, it allows you to configure policies for any network interface. That's going to be done with things like Calico or the native Kubernetes API policies. So that handles the layer 3 security level. The other option we have here is to use something like Istio for layer 7 network policies and routing for security. Together with those two capabilities, we can cover everywhere from layer 3 to layer 7 network security policies. So the request comes in and, granted that it passes those policies, gets forwarded to your worker and whatever services it might hit. So this is the ingress application flow. And then for external requests that a service might make, for egress calls, the same can be configured in Istio or Calico, going everywhere from layer 3 to layer 7. So that kind of talks about north-south traffic, ingress and egress, so communication with the clients as well as the data center or public-private cloud environments. So that tackles the north-south network flows. Next, let's talk about east-west. So these are going to be essentially communication happening between services running on-prem or in your public-private data cloud environments. So for east-west, going back to my analogy, so I badged into my building, they let me into the perimeter, but to actually get to my floor where I work every day, I have to badge again. And that's going to be it's actually the third floor of the building, right? So I go up to the third floor and I'm forced to actually scan my badge again. If I tried to enter the fourth floor, I actually wouldn't be allowed to enter as I'm not on the design team. So essentially what that refers to is a concept called segmentation. So within the actual building or an application infrastructure, maybe a public cloud environment, we want to create segments of what users are allowed to access, what admins are allowed to access, what processes are allowed to access when talking to one another. So at that level, we actually call this in customer or in Kubernetes environments, we'd call that micro-segmentation. So in the customer-managed environment, what that would look like is essentially setting up, using something like Istio, TLS between all requests going between microservices. The thing about encryption, it's one of those things that you want to encrypt any request as early as possible and decrypt as late as possible. So with traditional kind of Kubernetes microservices architectures, you want to make sure that all of those requests are being encrypted at the earliest level possible. So that's kind of handles microservice to microservice architecture. But we didn't really need to consider that with the monolith because, again, as we mentioned, monoliths would be using RPC or remote procedure calls, software-based calls, which remove the requirement of talking over a network, so we wouldn't actually have to take advantage of TLS. But you can imagine that you do want to make sure that the network calls made to the database would be secured to TLS. The next concept I want to introduce is what we have sketched out here on the cloud managed side of our cloud. So what we've got here is the Kubernetes master node. And one thing to kind of remember here is that when you're working with a managed Kubernetes service, the master node is actually going to be managed by the cloud provider. So whereas you control the worker nodes, the master is completely managed and houses a very important piece of the architecture, the etcd data store. So in the Kubernetes world, the etcd data store is something that you want to be really careful about protecting because that has all the information about your services, your deployments, and all of the Kubernetes API resources. So securing the etcd is going to be very important. It's paramount to your security architecture. And to secure that, a cloud provider traditionally will have a kind of a three-phase process. So what we'll have is everything from, we'll start with step one, which is authentication. So TLS. Next, we've got RBAC, which is Kubernetes role-based access control for authorization. And then finally over here, the last piece of that puzzle is going to be the admission controller, which is a Kubernetes concept that, once you've made it through the authentication and authorization, there's another level of security to make sure that those API requests are mutated or massaged and made sure that they're in the right format to access that data. So they'll access that etcd data, and to send that back to your worker node where your application pods need to request that information or pass information to it, there's a OpenVPN server. And there's also going to be a client as well. But that's going to enable you to basically access that etcd data store and return data back into the Kubernetes worker. So that kind of covers the pattern of how Kubernetes is set up in a cloud provider service with the master node being managed and the worker node being able to kind of work with that master node in a secure fashion to make sure your assets are protected at all times. The other thing I want to mention here, that etcd data store is going to be backed up. Let's draw this arrow here. That etcd data store is going to be backed up in a cloud object storage capability to make sure that, worst case scenario, you do have those assets in a secure place. So I think that covers, north-south network traffic as well as east-west, where we talked about network traffic coming in from clients, or at least network traffic going between services from your data center and your private environments, private or public cloud environments. The last thing I want to talk about is a concept called DevSecOps. You'll notice here that, it's essentially DevOps with the word security right in the middle. And essentially, it's a way to ensure that security is something that you think about from the ground up when you start architecting the application all the way until you move into production. And that's something you want to take advantage of to make sure that you don't have any issues when moving to production. You don't want to architect an application the incorrect way and then realize you have to go back and rework all of that. So thinking about security from the beginning is going to be an important thing. When working with a cloud-provided Kubernetes service, there's something that makes it a little bit easier to make sure your flows are secure. And one consideration you want to have here is to make sure that your CI workflow, that DevOps flow, has security embedded within it and is automated. So you can imagine maybe you have your favorite kind of code repository holding your application code, your Docker files, whatever they might be. You want to automate that process and make sure that maybe only the developers who are building that code have access to that Git repo. Next, you want to make sure you have a trusted signer to make sure that that code, when it gets pushed into a registry, we'll go ahead and sign it as a trusted image, which is something that's available with the Cloud Managed Registry. So we'll push that image into that registry. Once there's a capability called Vulnerability Advisor that's going to scan that image and make sure that there's any issues or any vulnerabilities that are detected everywhere from the base operating system to maybe the runtime that you're using, that if a vulnerability is detected, you'll be made aware of it. Once it passes that vulnerability assessment, you can tie that in to build that image and push it directly into Kubernetes. At that stage, you can use something like an admission controller, which we talked about in the Kubernetes master, an admission controller to make sure that that image is, again, secure and without vulnerabilities. And finally, there's a live scanning capability to allow you to scan your images running in production to make sure that there's no vulnerabilities in there. So DevSecOps, a very important concept that ensures that from the ground up, you're managing security when doing DevOps. Thanks for tuning in to part 3 of the Hybrid Cloud Architecture series on security. If you haven't already, be sure to check out the introduction, part 1 and part 2. The links will be below. As always, feel free to subscribe if you want to see more of these videos in the future. Thank you.